bring you on the topic of DevOps in general is what we're often approaching, but these series of two webinars is a follow-on from one last week, specifically looking at DevSecOps or SecDevOps, depending on your preference. Today webinar on a demo, really going early everywhere at scale with bringing security into your DevOps process. So I'll start with a little bit of housekeeping here. Go to the next slide. Yeah, great. Typically, folks always ask this, so we'll get this out of the way right at the beginning. We are recording the session today, and we'll make the recordings available later. We'll also provide links to the slides, so you don't have to worry about taking screenshots during the time. You'll be able to have access to all of this great content later on. Finally, we have built some time into the schedule today to allow folks to contribute questions for the presenters. If you look over on the GoToWebinar control panel there's a section for questions. Feel free to submit those as we go, and we're going to hold some time at the end. A few people did submit questions in advance, and it looks like some really great topics to cover already. But we would love to have more questions submitted to you during the presentation today. So we'll start with some quick introductions. I'm the person over on the right speaking now, Tim Buntel. I was really delighted to join Gene Kim and Derek Weeks from Sonatype last week or the week before to kick off this conversation about DevOps and security. We had a general conversation about how to bring the process of security and security-minded thinking into a DevOps approach to building software. A great ranging conversation on some organizational topics and motivational topics. But I'm thrilled this week because we're actually going to go and look at how you do it. So a much more hands-on, practical view of employing some tools to make this process, really achievable within your organization. So joined by two great technical folks, Ilka Turunen from Sonatype, solutions architect for the EMEA region, joined by XebiaLabs, Rob Vanstone, who is director of our solutions architecture team, both sitting in the UK today. So good afternoon to them. And we're delighted to have these two walk us through really practical approach to solving some of these problems in your own organization and why they're important as well. So I'm going to put myself on mute and sit back and turn it over to Ilka and Rob. I'll come back towards the end of the conversation to facilitate some of the questions. So I'll watch those questions as they come from you in the audience. And otherwise, Ilka, why don't I turn it over to you?
Oh, thank you very much. Thank you very much, Tim. And can I say what a pleasure it is to be here today? Me and Rob are broadcasting live here from our studio over in London. So hopefully everything will go through. So hello, Internet. Hello, everybody joining in on this broadcast. You may be wondering, who is this guy and what is he talking about here? So yes, like said, my name is Ilka, and I come from a company called Sonatype. So Sonatype is a company that's been out in the wild for quite some time. We're known in the ecosystem as the original founders of the Apache Maven project. So about around 2005, we were founded by Jason Van Zyl and Brian Fox, who were two influential individuals in the Apache Maven project. And the Apache Maven project, those of you who work in the Java world, is of course the world's most used build tool in that world. About 9 million developers every single day touch the tool and use it to build applications. And one of the biggest things that we do, kind of adjacent to Apache Maven, that's run by the Apache Foundation nowadays, is we still operate the Maven Central Repository. That is the backend of all sorts of different Java libraries that Maven interfaces it with by default. In fact, last year we had over 52 billion download requests alone from Maven Central. So we have a pretty good high-level overview of how the component ecosystem and how the open source ecosystem in the Java world works across the world. Our most famous product is something called the Nexus repository. It's a binary artifact repository that developers worldwide use to store their builds and their binary artifacts that they use as a part of their builds. Originally, it was a Maven repository, but nowadays it's a polyglot tool that helps developers store things like Docker containers, of course, Maven artifacts, NuGet packages, npm packages, you name it. It's one of the most popular binary artifact managers in the world nowadays, with about 125,000 installations. But one of the more interesting things for us is not only do we have products and tools that help you deal with binary artifacts or deal with binary components that get put into your applications, we also work with metadata about the components. And that's really going to be the basis and the perspective that I'm going to be taking in today's presentation. We, in fact, last year saw over 5 billion requests for, not for components, but for component information. And we've amassed over the years quite a significant database of component knowledge that we're going to be walking you through today.
Great, and likewise from me, my name's Rob Vanstone, and it's really great to talk to you all out there. I work for XebiaLabs, and what XebiaLabs bring to the table here is that knowledge of, and we've done this now for a good 9 years. Before it was really fashionably called DevOps, we were helping developers get the knowledge of the applications and the bits and the bytes onto the machines so that operations could actually deploy these artifacts that we're going to talk about today in a reliable, safe way. Latterly, what we've developed is a second product, XL Release, to manage what is now becoming a very broad spectrum of capabilities of getting my releases in front of my customers, or getting the valuable I guess software that we're developing, because we're all software companies pushing out ideas and features in front of our customers through the pipeline or the value stream in front of our customers. And we do that by orchestrating across many of the tools used today. So CI tools, repository tools, testing tools, and service management tooling, right up to the operation end where we integrate with monitoring tooling. And that's XL Release. And we'll talk a lot about XL Release today because we're very excited to start to show the integrations with Sonatype Nexus IQ. But it's really about pushing those ideas in front of our customers in a consistent and secure way. So it's much more than DevOps, which is why the title is loosely called DevSecOps here. And we'll go through this in a lot more detail. And the reasons why we're going through this is going to become apparent as we move through this.
Yeah, absolutely. And I think a great place to start this conversation. So I think we're actually a very, very good match between ourselves, between Sonatype and XebiaLabs, because we kind of deal around the same issue. You know, at a very, very high level, nowadays, one thing that stands out to me is everybody can't stop talking about hackers and hackers everywhere. You know, no matter where you look, every single day we find a newer article about, you know, this hack happening here or that hack happening there. And it almost seems like we've reached a point in software development where software has kind of permeated our society, not only just our enterprises, to a point where, you know, any fault or any compromise within the kind of security of software gets headline news and gets headline attention. We got plenty of examples of this thing happening. Like, for example, those of you who are into chatting tools, you may have seen that you might have had a little password reset request.
Yeah, definitely. We've had all the notifications as well.
So there was a bit of a slip chat at HipChat. More interestingly, we've seen, for example, hospitals being entirely shut down because they got hit by ransomware that was launched from within. So essentially, I saw a hospital in Maryland actually got all of its systems locked out last November. Last March, actually, because they had some ransomware that got installed. So instead of getting a hospital tools, you got a Bitcoin request. There was another famous story a few years ago on Wired about hackers remotely killing a Jeep on the highway when the journalist was actually inside of there. And if you read into the story, they actually managed to do that through the cam interface inside of the car. Most recently there was a little blunder in San Francisco where the municipal system got hit by hackers. Where they've installed the exact same ransomware actually as in the Maryland case, and for a day, if you try to buy a municipal transport ticket, you actually got the ticket machine said that you can have your ticket if you pay me 100 Bitcoin instead.
Yeah, and it, this in the news, this is really prevalent, and actually getting the scaremongering and the hacking is on top of people's lips, and I guess that's the point. There's a lot of noise out there, and it doesn't take much to cause that. Yeah,
and the thing about noise is with a lot of noise, people feel a lot of pressure to do something about it. Probably. We've all had that manager come up from the ivory tower, come and slap us with a manifest.
Guys,
that says,
can I just interrupt you? We're not seeing your screen. It says waiting to view Rob Vanstone's screen, but we're just seeing the presentation screen or the main screen.
Okay, has that just happened, or is that?
It's been going for a while. I tried messaging you, but you're not looking. So I'm sorry to interrupt, but can you check that?
Can you see it now?
Presentation. Perfect. Thank you.
Okay.
All right. So you've heard us
live.
Perfect. You've heard us have a conversation, but just to say,
yeah, well, we've been hacked. So
this is definitely one of those situations. So, like said, you can find examples of these kind of articles everywhere. But I think a very good illustration of the status of understanding what this kind of all hacking business really means is well illustrated by the background image here, which is from a news report not too long ago. Where the background image to illustrate hacking actually comes from a video game, because probably the newsroom thought that that looks like
code.
Exactly. The truth
Let's
is,
be scared of software.
Yeah, the truth is, for years we've been saying, Mark Anderson quite famously in 2011 said, software is eating the world, and I feel like we as a kind of industry and we as a profession have kind of gotten stuck into that mode where we're thinking, software is going to creep out, from everywhere, and it's going to eat our livelihoods, and we're going to have to get a little bit better at this sort of business of managing it. But the problem is,
well, yeah, I mean, you talk about this, and we're fearful of this happening. I mean, what the case is, software is what we do now, right?
Yeah, exactly. The truth is, we're still in kind of that mode where we think that software is going to eat the world. But if those articles that we showed you before say anything, then to me at least it says that software has already gone and consumed the world and chewed it to bits and spat it out again. Software is everywhere in our lives, and one of the big things about that is how do we deal with the aspect of quality?
Yeah, and where do we start? I mean, traditionally, it's always been this thing that fairly late on in the development cycle, we throw this over the fence and get what we've developed ratified or inspected, or traditionally, the concept is it's a bottleneck that because we're being blocked.
And who hasn't been hit by the legendary pen test that hits when you least expect it and when you most need to be able to release activities. So the truth is, as a kind of profession, we've moved on to doing DevOps and continuous integration and delivery. But one thing that hasn't really changed is this notion of how do we deal with quality or security or governance. I really like this quote from Edward Deming from his '82 book Out of the Crisis, where he actually went through and said you cannot inspect quality into a product. So for those of you who don't know, Deming's ideas are actually behind lean and agile development and software delivery. and they are very much a founding baseline for lean and agile. But one of the things that hasn't really been stolen from Demings yet into software delivery is this notion of quality control. One of the biggest things that Deming said was you cannot inspect quality into a product. You have to wean that quality control into the production process of that particular product itself.
And it's a continuum, right? It's something that we should be constantly vigilant about, and it's not something that you save to the end as an inspection, right?
Exactly. And where do you start then? How do you start building quality into a product? Well, one great list from a security perspective is this. The Open Web Application Security Project Top 10, or as they call it, the OWASP Top 10. The OWASP Top 10, for those of you who don't know, is a top 10 list of the most critical web application security risks. And it's a great little reference that kind of teaches you about, here are the top 10 things that, cause risks within a given application. It's got things like SQL injection, not validating your inputs, these kind of basic software 101 things. But one of the most underlooked and actually most used items in this particular list is the A9 list. A9, or top 10 number 9 from the 2013 list, is using components with known vulnerabilities. So one of the things that we've noticed as Sonatype is that as we've kind of started carrying this component ecosystem and serving it, occasionally we do get asked the question of, hey, this component has a known vulnerability. Unfortunately, that's quite a complex problem. Not every component has an issue, and even if I have a problem with that security vulnerability, you, Rob, might be fine with using it.
Yeah, and this is about risk, right? And we'll talk about this a bit later on. But if we at least know about these risks, then that at least gives us something to work with. However, we just decide to mitigate them.
Exactly. Now, one important thing to mention about this list, though, is it is referenced by a huge amount of standards and a huge amount of pieces of legislation, especially here in Europe. You often see it referenced in CERT and those sorts of organizations. So, people have been trying to do something. Some companies have tried to do something about it. If you want to see a little bit more of the references, tune into last week's presentation with Derek and Jean, where they actually went through these numbers about how many companies have policies about it. But either way, whether or not you have a policy, this is actually a particularly complex problem to solve. I find that this is well illustrated by the visualization that I'm showing you over here. This is actually a visualization of all of the artifacts that were found in Maven Central in the August of 2015. It kind of looks like an organic being floating up in space, doesn't it? But what it is illustration of all of the components there. So on the right-hand side in that little zoomed out bit, each of those white dots that you see over on that side are actually individual artifacts, jar files that you can download from Maven. And those orange lines between them, they're actually one component's dependency to another component.
Wow.
So as it turns out, if I use some libraries, those guys who use those who produce those libraries also rely on some other libraries, who rely on some other libraries, and that transitive supply chain gets really, really complex, really, really fast.
Yeah, it's mind-boggling. And how do I, as a technician, begin to know what affects my use of a particular feature or something that I want to use in my application? How does that affect my organization? I mean, to me, when I start to do Maven commands and things like that, I just see a scrolling list of these dependencies, and this is what I'm seeing.
Yeah.
And now I've got to go through those and figure out.
Yeah, and at the same time, your manager is probably telling you that the software should be out yesterday, right? That's what we're really paid to do. The problem is it's not really a unique problem to the Java ecosystem or to any other ecosystem. You know, another great picture to illustrate is this very contained sample of a JavaScript file and its relative interdependencies. One of the things that we've done is we've audited through loads and loads of different component catalogs, things like npm.js and Maven Central, etc. And what we found, for example, is that although there are 80 million JavaScript files that we looked at in one survey, we found that only 6 million of them were unique. So you might find cases where, you know, things like jQuery.js is actually embedded into other artifacts as well. So you might have jQuery in a Java artifact somewhere. How do you manage the security risk coming in from there? Do you manage the outer component? Do you manage the inner component?
Yeah, so we've got nested situations.
And in many companies where what they end up doing is where they just start to look at these sorts of issues, you know, it might seem logical to just say, hey, we'll just approve a couple of components and we're going to use them. But as these kind of transitivity graphs show and kind of prove, is that, you know, there's a lot more than meets the eye and a lot that gets hidden kind of under the surface.
It's huge, right? And again, this is all against the backdrop of delivering faster and shipping our features as quickly as possible to our customers so that we can get the feedback from them so that we can improve ourselves and offer a better service. And that's why practices like continuous delivery and the automation we see to help deliver that become mainstream. But really, if you automate that pipeline and you've still got issues like the vulnerabilities that we've talked about, all we're saying there is, well, we can deliver this stuff much faster and still push this stuff out in front of our customers quicker, being just as vulnerable. So, you know, how do we start to address this in amongst the pressure to deliver early and often, and why are we doing this? What's the reasons behind this? Well,
and the truth is, you know, you can go as fast as you want, but you know, if you go, you can also crash into a wall very, very fast, and the faster you do that, that's going to be painful, right?
Well, it can be, but you know, we learn from our failures, and it's not about failures being, you know, something to avoid, but we need to know what this is.
Yeah, absolutely. And I mean, I don't want to dive too much into software 101, but you know, one of the earliest things that at least got drilled into my head when I started thinking about this profession was that you know, as software or source is being built and bundled into applications, you know, libraries and source code that you write yourself, and those get deployed into containers or virtual machines or whatever, and these are provisioned into full information systems. Kind of conventional wisdom says that the mean time to remediate a quality issue is about 10 times faster if you find it during development rather than in production.
Yeah. So that time to recovery is much quicker. And
yeah, exactly. And that's kind of the basis of all of these lean and agile and DevOps movements is you know, if you can tighten up this loop and make this development side much faster, we're going to have much less quality. But the truth is, from a security point of view, one of the biggest things you can actually do is, since so much of our applications nowadays is third-party code, actually the fastest thing to do is remediate to fix quality issues is actually not have those bad components in there at all.
Right at the beginning.
Right at the beginning, yeah. And I don't mean it in a kind of scan your code and, you know, find all of your flaws. I mean, make sure that whatever library you download actually doesn't have any documented vulnerabilities, or it doesn't at least have very critical vulnerabilities that might affect you specifically.
Yeah, so thinking about security right from the outset.
Exactly.
And this is all about making things cheaper, right? And Gartner have recognized this. These metrics here, and we will dive into these metrics in a follow-up webinar. These metrics here are some of the things you can track to help drive this story.
Yeah, and so I find that the theme of security actually fits really, really well into the overarching story of development. So, you know, DevSecOps, the titular movement in this title, is actually both the movement and a website. DevSecOps.org is a website that contains, among other things, some very, very good pieces of information about what to do in order to start, introducing things introducing security better into your development pipeline. One of the nicest things I like about there is it's coined by someone called Shannon Leeds, who regularly does these conversations. And what they've done there is they've actually come up with a security or DevSecOps manifesto. Like I said, often security is treated as kind of like an afterthought. Security staff developers outnumber security staff by 101. So the kind of temptation of security just to become kind of rubber stamps that approve development is very, very huge. So it really focuses on this kind of enablement that security should actually become a part of development in the tools that development use today.
Yeah, and make it obvious that this is what we're doing. Make it transparent.
Yeah, exactly. So that's really the kind of idea over there, and to kind of make it concrete, I think one of the best things we should be talking about is, well, how does a typical development pipeline then look, so that we can talk about how we can get security into there. Well, the typical development pipeline really runs, where developers start by checking out some source code from a source control mechanism like Git or SVN or whatever. To support their development, they'll also download some third-party components from public component repositories like Maven Central or npm.js or the NuGet gallery. And hopefully they'll have some sort of artifact repository in between their connections, so that if the internet goes down or something like that, they still have a cached copy of the components that they're using. Now, developers develop, and that triggers a commit, and that commit triggers a build. Build hopefully uses the same dependencies, and that triggers then a deployment into whatever environment that you want to deploy. If you're doing the kind of Dave Farley type of idea of continuous deployment, then you'll build once and actually deploy into various environments. This is kind of what we see as continuous integration and development. It's been a great movement, but it hasn't really seen much interface for security so far. So from our point of view in Sonatype, managing this kind of supply chain of components should actually be part of all of the other activities that you do during this CI/CD pipeline. It actually starts with codifying rules for your developers to follow about your dependencies, and then running those rules, or policies as we call them, as early as the first build. So actually to give developers early feedback about which components have known documented security vulnerabilities or other kind of quality issues. One of the greatest things about this is if we build those rules right, we can actually use them to block bad stuff from being ingested in the first place. But the most benefits you of course reap if you run it during CI/CD time, and make your components trusted by somehow default. And one of the things that we're going to be talking about today is you can actually interlace these policy enforcements throughout every single activity that you perform through your delivery cycle. And finally, of course, components don't age like fine wine. They don't get better with age. They age more like milk. For a long time they're good, but you got to keep an eye out for new issues.
Yeah, especially in the enterprise where some of these cycles can take a little bit of time.
Exactly. So the way our kind of respective products fit into this picture, Rob, is that we deal with the repository by our Nexus repo. We've got something called Nexus Firewall that deals with this. And we got something called Nexus Lifecycle that does the rest of these policy enforcements. We do this by having loads of different interfaces to different kinds of products, things like IDEs, things like build tools. But most importantly, I find that one of the best ways of facilitating awareness and better understanding of this whole pipeline, it's quite complex, isn't it? Is that you need to have some sort of agent on top to manage this kind of work.
Yeah, and we can glue this process together with some, with Excel release.
Yeah. So let's start the demo and do a quick visualization of development all the way through to production. So what I'm going to do is I'm going to start by just showing you, the life of a developer, because like I said, this is the place where you're going to reap the highest benefits of the security process. And what I have here is just a typical Java application that I prepared earlier. For those of you in the know, it's actually the OWASP spreadgoat. It's a deliberately vulnerable one.
This is in Eclipse, right?
Yeah, this is in Eclipse IDE, just because I like Eclipse, to be honest.
Okay.
What I have here is a series of dependencies. This is the Java syntax, but it looks pretty much the same in JavaScript or Ruby gem file or whatever. Usually you have some sort of package manifest that tells you about what package you're using. But what this syntax isn't very good at telling me is well, is that a good version of this component to use, or does it have any known vulnerabilities, or even what does activation do? A big part of being a good software engineer is just being in the know. So even if I wanted to do the right thing and maybe find out about this component as it gets put here, pretty much the only thing I can do is copy paste this, go to Google, land on the Stack Overflow thread, and
so do a Google search.
Yeah, exactly, and that can easily take hours. I've heard anecdotes where people say, I can sink 4 hours into research on one component. And now think about the fact that an average enterprise application has about 100 of these dependencies.
Yeah, and I'm just thinking of that picture you showed earlier with the dependencies.
That's a long time. So what we do is we have plugins for different IDEs and different parts of the CI/CD pipeline that actually pull out that information for you. So what you can see here is I've got a list of all of my dependencies here, including transitives, and I can actually see that they're already traffic light ranked in a kind of, red is the worst type of thing. So already as a developer, I'm getting contextual information from my tests. The red stuff didn't pass the muster, and I probably got to address that. For each component, we can see things like coordinate information, licensing information, both from the source and the original metadata. But of course, not only are there evil lawyers, there's evil hackers. So we can tell you if there is a known security vulnerability on this component, and if so, how severe it is on a scale of 1 to 10, 10 being the worst. Now, we also tell you about architectural information, like how old is this component? Well, this particular artifact is about 9 years old. So I should ask myself the question, is there maybe a newer version that I could be using? Has this been updated? Does it constitute a tech debt? A tech debt that I have almost a tween component inside of my CI/CD pipeline, right? And finally, we can also tell you if it's an exact canonical copy of something that's found in Maven Central. Now, all this info is good, but what really makes this thing tick is the fact that we can give context to this information by introducing these policies. Developers aren't security or licensing experts. No, should they be? They should be focusing on delivering new value and new features. So what we allow you to do is actually define on a per application basis policies that tell me as a developer what is the rule set that I should follow. So here I can see that my security guys have set me a rule that says they don't want to have any known documented security vulnerabilities with a severity between 5 and 9 on that 1 to 10 scale.
Okay. And we'll see when in the process that they could do this a bit later on.
Yeah, and I can also see a licensing analysis, and finally a broadcast of what the vulnerability is. So I can already see that there's a huge remote code execution issue here, probably a really bad version for me to use. I can actually use some of this tooling that we have here to find a better version. So this graph here is actually a complete release history of this particular component, all the way from version 1.0. The red triangles here tell me that that version has a known vulnerability. Boxes tell me about licensing, and these graphs here in the top tell me about the popularity of that component. So I can actually use this. If I find a better version that doesn't have, the red triangle, I can actually run the tests automatically on the fly and see if that version would be any better for me. In this case, it seems pretty good. It doesn't break my policies anymore. I can actually go to production with this. So perhaps the easiest thing I can do is click on this migrate button, have it replace my declaration with a newer my pom.xml declaration with a newer version, and recompile it right here locally, so I can get a feeling of how would it actually look like. Imagine that. I just mitigated a major security issue in a matter of seconds, without or in a matter of minutes, without even thinking it. That's the power of giving information to the right people at the right time.
Yeah.
So I'm going to pass it back over to you, Rob, and we can take a little bit of a higher perspective of this.
Yeah, definitely, and I think that's a really good starting point, because we've got the development and creating these and reducing as much as possible the amount of stuff that's coming through our pipeline. And as we've said, we have the ability now to model that pipeline using XL Release to get those artifacts, and we probably now think of them as an application through our value stream in front of our customers. And when we're doing this, depending on how long this takes, I mean, ideally, if you're talking about the unicorns of this world, we're doing that at commit time anyway. But, really the reality in most of our customers right now is that's going to take a little bit of time.
Yeah, absolutely. And I feel like, DevSecOps isn't exactly a kind of be all and end all. It's more of a journey. And I think a big part of understanding security and introducing this kind of automation into your pipeline is having a visibility of how that actually looks like. A big part of DevSecOps is also illustrating that value stream.
Yeah, and getting that transparency, and that's what our products are able to do. So what I'll do is show you the next part of the picture. I'm conscious of time. Normally we would give a really big overview here of XL Release and the way XL Release can be used to model your pipelines, and I'm happy to give that demonstration in much more detail. But the bottom line is I can take my release process and I can model it, and whether that's just automated tasks or a mixture of automated and manual activities, this is something we see pretty much all of the time. We can model that process and we can start new releases through that process.
Yeah, I really like the fact that it's got both automated tasks and manual things, because one of the biggest problems for me is as a developer is I understand what I've done with my Jenkins pipeline, but it's very hard for me to kind of get, who do I need to talk to get that approved and all of these things.
Yeah, and that's it. And the teams that we deal with here are really first-class citizens, and it's this visibility that we concentrate on. And when we're running through releases, and by the way, these are, if you have the right privileges and permissions, these are easy to do, you can capture information. Now, this is the bottom line of what XL Release is designed to do to improve your release process. And all of this information feeds into visualizations about how good you are at software release. And it's these metrics that can then help you focus on the issues that are causing your delays. And it might be today, this is your, you've thrown the package over the fence to your security team and they've got a huge desk full of stuff to review, and it's taking them a long time because they're heavily under-resourced compared to maybe the features you want to get out there. So when we put this in the context of, say, something like the application we saw from Ilka's development side, so we'll pick on our poor WebGoat application here. We're talking about pulling in all of the activities to get this application right through the process in front of our customers. And, we can model that process. And actually, I've done most of this through XL Release as automated tasks.
Oh, that's really wonderful.
Yeah, and because XL Release can integrate with the tools that you have at your disposal in your ecosystem, we're now talking about interacting with your CI tool. So that the point at which I want to cut a release, if you like, and this is something that we may do, a fairly regular cadence, I can specify this. I can provide minimal amount of information. So already we're making this process generic, so it could apply to all of our applications. We're able to use features that are really standing out now as good practices, blue-green deployments or canary deployments. We can pull in information from our development teams to say, right, this is what we want to go live. And when we start this, and we start executing on these, this is where we built in our discipline. Yeah. And if we're a tools vendor, obviously we're going to promote the value of tooling here, but we have sat down, we've got the stakeholders who are all representing this value stream together to identify how we get our software out in front of our customers, and we've baked in some of the principles that really matter to us. Now, I've added a couple, just for the sake of argument, a couple of manual tasks in this process. So while the integration testing happens, we can already see that we've engaged people in our security culture to look at those policies that you were talking about earlier.
Yeah, absolutely, and it's great that, you know, we can kind of have this kind of checkpoint for making sure that we're working against the right rule sets and we're having the right things to go. I really like the fact that I can actually see the arrow kind of jumping down, up and down in the lifeline. So
yeah, so as we move on, and here we're just integrating with the tooling that you guys use anyway. So, you know, your ticketing tools, where we've pulled all of the tickets in this sprint, because we know we're going to use those when we raise change requests. But right now we've said, right, product owners, we've got a new application. We're happy that it can integrate. Are the policies up to date? You know, what do you have to do to make sure that those work?
And that is something that is actually done quite well with our Nexus IQ team. So the demonstration in the IDE that you saw earlier actually interfaces with our IQ server, which is, you know, a server that sits in your CI/CD pipeline, and this is where the rules come from. So the rules that we can specify, the policies, can actually be specified on a company-wide level, team-specific level, or even on an application-specific level. So we can go in and specify pretty much whatever granularity we want, because, you know, an internal dev tool isn't like a revenue critical tool, for example. And each of these policies we can go and check. And as an application owner for WebGoat, I can actually go and see, hey, this is the rule set that I'm playing against. I can click on them and actually pull out the information about what that policy is, so that I can know whether or not to interact with it.
Okay, so WebGoat is the application that I want to deploy, and I, as a policy holder here, have said, okay, in the staging environment, I actually might tolerate maybe an evaluation of this library to only warn me if there's a problem. Is that what you're saying?
Yeah.
And once I've assessed those policies, you know, I have a job to do in XL Release. I can say I've done my piece, I've done my due diligence, and we're auditing that. And we're actually tracking as well how long that took. And now we've got the idea of another team that maybe is going to accept those changes.
Well, let's get the team to accept the changes, shall we? And
yeah, we'll move through this. So again, they can move through this, and they're signing their name and saying, yes, we accept what's happened. And XL Release actually is really quite good at providing all the information you need and allowing you to make the decisions to do this properly. So we can complete these tasks, and then we can move on.
Yeah.
Now, again, we're talking to other tools you have in your organization, so we've raised a change ticket.
Nice. And what's happening right now is one of the cool things that I mentioned earlier is we have plugins to various different environments, and you've come up with a plugin to our Nexus IQ. And what's happening now is we're actually checking the deliverable against those policy rule sets that the developer could already see, and actually seeing whether or not this can actually go into that staging.
Yeah, and because time's moved on, we're seeing if that thing is still valid, and as we can see here, it's failed the evaluation. So we're failing as early as makes sense, and when we look at this failure, we can see, you know, we can start to look at what's gone wrong here, and we can see that it's actually failed because we have a policy failure. Yeah,
so what happened here is this actually went through the whole deliverable, fingerprinted all of the artifacts that we found inside of there. So we actually looked at the final WAR file that we were about to deliver.
This is that nested thing.
Yeah, exactly.
All
so
the dependents.
Exactly, so we can get all of the transitives over there. And what actually comes out is a policy output. So we can see that there's 11 critical policy violations in here. And one of the coolest things about our IQ server is it actually creates a report, a bill of materials, if you will, of all of the artifacts that we find inside of that given report. So we can actually see that this application had these components inside of here, and the reddest ones are the worst ones. I can actually click on them and see the same tools as the developer did. So even if I'm not a developer and I'm not using the IDE plugin, I can still use the same tools to kind of identify a better version. But one of the coolest things that we do as a company is it's no coincidence that I'm using web code. Actually, a lot of the individuals behind web code actually work in our data science team. And what that team does is we actually look at various different security feeds as well, and we enrich a lot of that data. So we provide you with a lot of information about what the security vulnerabilities actually are. Our aim is to be developer friendly, so developers can actually understand the security issues, because often security bulletins are very kind of high level and they're meant for that security guy to kind of decipher. So we kind of do that for you. So as a developer, I can read that there's a faulty class in here that will get malicious code to execute system commands via Java reflection. But I also get detection guidelines. What do I look out for, and how do I fix it? Recommendations. Yeah. Hey, upgrade to a newer version.
And this is that transparency again. So we're seeing that at all levels of this delivery pipeline.
Exactly. And if I want to, I can actually jump into our projects. So the theory, of course, is, as we go along in this project, I will go through all of these issues. I will handle them one by one. I can, of course, get a raw view of these as well. Yeah. And hopefully the quality of the application will go get better.
Okay. Well, could you, for my benefit then, could you make it so that, okay, there is a risk with this application. We've done the analysis, but I actually want to mitigate, I want to allow it through at least staging.
Well, let's change the, this is something that you would not do in production, but let's turn back time and change the policies a little bit and make sure that everything gets through. So I'm going to temporarily waive the stopping policies away so that we can progress.
Yeah, and that's just to give the kind of flavor here that in XL release, and this is again another benefit of orchestrating this pipeline in a very visual way. We can retry that activity. So yes, we've made a decision. We've updated our risk register. And we're retrying, allowing through staging so that we can fix this, but still smoke test the end result. And all of this is audited and logged. So we're doing that evaluation again. We know what we've done here, and what we're about is pushing the knowledge of these risks through the tool so that at least we can make those decisions. I could clearly abort the release at this stage.
Yeah. And one of the beautiful things about how we interfaced with this is that the developers hopefully will have mitigated a lot of those issues in their IDE already, because they saw the same issues happening over there. So
and again, it's all about pushing this information to the right stakeholders. So again, another feature of the plugin we wrote to integrate with your software is the ability to dashboard this stuff at a summary level.
I like that. I like how visual it makes things. So we can actually see the security issues that we're having here. Yeah. And it seems like we're almost into production, hey?
Yeah, we are. And obviously you didn't allow this to go through the production, so we've still got that gate that's gonna stop us here. So I'm fully expecting this to fail. And this is a live demo, so anything can happen.
Anything can happen. Yeah. But I think at this point it's worth mentioning that we also provide a little bit of reporting here. And so it's all great if it works in one application, but what really makes this stick in my eyes is it needs to scale to an enterprise level. Yeah. So we actually give you a little bit of visibility about what are my worst components, which components are the most risky, or even a wall of shame of your worst offending applications. So I'm seeing that our example projects are very, very risky. So we know where to start essentially.
Yeah, and okay, and disaster has been avoided. We've skirted over deployment. We won't need to go through these any further. We can go and fix our code because the vulnerabilities have been detected. So that's really a summary, I guess, end to end of where we can get to with this, and we've got.
Yeah, and imagine what we just did here was a full release with human manual steps. And with automated security controls, automated risk prevention, without touching a button, we just looked at the reports.
Yeah, and made decisions on the data. No, that's great. So going back to to summarizing where we've got to, and maybe open the floor for questions. It's about building the knowledge into this and then making decisions about how you want your process to flow through.
Yeah, and DevSecOps necessarily doesn't mean that you overgo all manual steps. People still exist, and unfortunately, as long as people contribute to software, there's always going to be some manual things. But you should automate the easy wins. You should look at these kind of easy policy violations and make sure that preventable security issues and quality and governance issues are taken care of. So the one security guy amidst 100 developers can focus on the really big exceptions, the really big problems, and not worry about routine that kind of bogs you down all the time. So just to kind of summarize, what we just showed you was a pipeline through development, where the developers used an access lifecycle tool to kind of prevent builds from completing and builds from being deployed, thanks to the Excel release plugin. And one of the things that we could have showed you later on is we have interfaces for issue management tools. We can actually open tickets up directly if these vulnerabilities do exist, or present a status to GitHub as an example. So it was really great to see how both of us can kind of really help you see kind of high and low level of what the delivery is.
Yeah. That's great, and I'll hand back to Tim to moderate the rest of the session and to give you a little preview of what's coming, and I'm happy to take any sort of questions after that.
Yeah.
Tim?
Oh, sorry, come off mute here. Thanks so much, guys. Yeah, really terrific walkthrough here. And we do have a few questions, but before we get to that, I just do want to point out we'd love to have folks come back and join us in May for the next webinar. This is a topic that's near and dear to my heart too. Nicole, who's our presenter for this, she and I worked together at the DevOps Enterprise Forum in Portland just last week on this very topic, right? So what are the things that you can look at to make sure that you're on the right track for DevOps success? So a bit of self-assessment and metrics, and really looking at the measurements that tell the story of your progression for DevOps. So it's a great topic, great presenter, and we'd love to have you back. So here, let's try to do just a couple of quick questions in the remaining minutes here. We saw a lot of great pieces in the demonstration here, guys, on the pipeline. I've got a good question that came from a user for earlier on, right? So the question was, do you have any recommendations for the seamless integration of security requirements into product team backlogs? So what do you do in the beginning? So intake, tracking, prioritization of these kinds of things before you even get to the process of build and deploy.
Well, I mean, a big part of that is actually having the right information in your fingertips at the right time. So often, during design phase, one big decision in software engineering is, which frameworks or libraries we should be using. And often those decisions, in my experience at least, kind of come from a I know this, I have a feeling that this technology is good, or alternatively, hey, let's try something new. So at that point in time, one of the things that we can actually do is we can interface with, obviously, the repository manager, and you can actually use that to also get policy outputs about the components that you might be using. So instead of choosing bad components, in the first place, you can do a little bit of research about what would be the right set.
Well, I guess you get as well a bit of a history if you've got the mainstream components out there of over time, how good are these things and how quickly are they fixed? Because everything starts somewhere. So
correct, and a big part of kind of managing the supply chain is actually standardization as well. So once you find something that's good and that works for your organization, standardize on it as well. Make sure that other teams will start using that particular tool set as well. I used to reference that you wouldn't want to come, a car company that uses 400 different makers for brake pads. Just as a company, you wouldn't necessarily want to use 500 different logging frameworks. You want to standardize on a few and then make sure that you know the ins and outs of those, both from a security and from a kind of software engineering perspective. So I think that's quite a good starting point.
Great. Here's another question which just came in that touches on some earlier webinars that we did, but I think it's a good question for both of you to address too, is how does this work when you've got mainframe as part of your applications? Does it have any changes, or does that influence any of the story we looked at today?
Well, from our point of view, what we showed you today actually addresses the Java, JavaScript, and .NET ecosystems. So we obviously come at it from a kind of 4th generation language onwards. So often, unfortunately, within the mainframe world, you know,
it's still quite manual, I guess.
It's still very manual. So I think especially the release management bits really fit into quite well. The thing about those kinds of environments, though, is often this kind of a notion of open source ecosystem doesn't really actually exist. It's really just source code that gets shared with individuals anyway. So this kind of
small code quality.
Exactly.
Yeah, and again, the principles from a deployment and release perspective still apply. What we're trying to do here is settle on a number of release processes that get the right people making the right decisions at the right time, and we can model that, and we can actually execute that. And that's where we start to see, have we got a problem here? Because if our releases are failing because of vulnerabilities or security issues, we will track that. And that will become a pattern that we need to address.
Great. A good question here that's touching on static analysis and some other analysis tools. So how would this all play in if a team was already using something like Fortify or AppScan to find security vulnerabilities at code level?
Well, from my point of view, it's an easy answer. That's actually a complementary activity to what we're doing. Because if you really think about it, those kind of static code analysis tools are really good at picking up faults in your own code and, you know, execution patterns that you really shouldn't be doing. And it's a great activity to perform. But unfortunately, in my experience, you know, in a bigger code base, that also is an activity that takes a long time. So it should still have a role within the release pipeline, but what we're showing here is all about preventing known and documented risk in code or binary artifacts that you're downloading and using already. So really, they're kind of two sides of the same coin. Make sure that the binary bits that you're using from the outside are good. And then, you know, it's kind of complementary to static code analysis to make sure that the things that you write are also good.
But you can still fingerprint those things that you write and get the meta.
Yeah, if it's packaged in a Maven artifact or an npm package or a NuGet package, yeah, sure. So you can actually manage your own libraries as well through this. But the kind of baseline is static code analysis, kind of its own domain of issue.
Yeah. It's a different test.
Yeah, exactly. It's another test. And in fact, we see deployments where static code analysis is a part of the release pipeline very, very often. It's a key component of actually a secure deployment pipeline.
Right. And I think you touched on this already, but just to clarify, so someone asked, which was the tool that was doing the analysis and recommending the upgraded version of the component? And the specific question was, does that work on NPM packages besides Java components? So I think you just answered that, but go ahead, Ilkka.
Yeah, absolutely. So this was Nexus Lifecycle, working in conjunction with Excel Release. And indeed it does. So it works on Java, JavaScript, .NET ecosystems through there. So yeah.
Yeah, and again, for our part, the tool that's orchestrating this is agnostic of your package types. We're just pushing the delivery of those applications.
Perfect. Well, we're at the top of the hour, so I think we're going to wrap up there. Those were some great questions, and really thank you so much, Rob and Ilkka, for walking us through this. I think it was a great view of a situation that was really lifelike and one that I know I've seen time and time again. So really appreciate the walkthrough. Thanks everybody for joining us today. Look for the recording and the posted slides later if you want to follow up with us. We'd love to hear from you. So thanks so much.
Thanks everybody.
Thank you all.